Thank you for the opportunity to present my work here. Again, my name is Claudio Egalon. I am with Science and Sensors in Los Angeles. And what I'm trying to do, or what I'd like to do, is commercialize a new type of colorimeter that uses an optical fiber, a side-illuminated optical fiber. It's a technology that I pioneered back 25 years ago. The problem that we have addressing right now is the problem of nutrient contamination in the environment. It's a pressing problem that has been around with us for thousands of years. And something like that has been documented in the Bible and the actual book. If you watch the movie, you remember that the Nile River turned red, which was actually because of what we call red tides today. And nowadays, because of industrialization, the problem is even worse. Okay? Not only can it kill marine life, but it can also kill human beings as well. Another problem also that similar to that is the contamination by nitrates that cause baby blue syndrome in infants. Okay, here's a picture of the red tide. Microorganisms that when they multiply on the water, they output toxins into the water and turns the color of the ocean into red. One of the colors is red and kill any of the marine life that you see right in here. Okay. The instrumentation that's used to determine the degree of contamination can handle only one sample at a time. Think about that. If you want to measure several samples at once to speed up your process, the instrumentation that exists out there can handle only one at a time. Okay? And that's what our competition has out there in the market right now. What I invented is something that can handle multiple samples at once and even simultaneously. Here, that's how it works. The regular colorimeter available out there in the market. You have a sample cuvette with your water sample. Initially, the water is transparent. You mix it with a chemical, and then the water turns into a color. Depending on the color, it's going to absorb more or less light. Okay? And that's what we have here on the left side. We have a light source, the cuvette, the sample that's going to absorb light, and this detector that's going to determine how much light has been absorbed. Okay? That's what the competition has out there. And if the competition needs to measure multiple samples at once, they're going to need several of those instruments. Okay? Yeah, I'm representing 3 instruments, and the most expensive portion is those detectors right here on the left, on the right side. So, using optical fibers, we invented a novel way to cut down the number of detectors. Okay, here's my optical fiber, here's the sample cuvette, and again, here's the competition. Okay, notice that we can eliminate all but one of the detectors. Those detectors can cost anywhere between $150 to $50,000. So for this specific case, we are saving at least $100,000. And remember that we can analyze not just 3 samples, but even 10 or 20. Okay? All depends on the length of the fiber. Next one here you go. That's how our solution works. Here's the little nothing that can save you hundreds of thousands of dollars, 40 cents a meter. Okay, our light is probing one of the cuvettes, one of the samples, and the light couples into the fiber by side illumination. That's a unique way of coupling light into the fiber. I was a pioneer in this technique. That's what we call side illumination. Let's go back here. Here is one of our products. You can see the optical fiber runs through this support, and this other support has our light sources and the cuvettes. Okay? Light is illuminates through the cuvette, illuminate the fiber, and light is coupled into the fiber to the detector system. I have one of my products right here with me. If you want to see it, I can demonstrate it. Okay, so how we are sizing this opportunity? There are many applications of this type of device. Okay, so the first thing that we want to do, we want to market it as a lab experiment for undergraduate students. With cash flow from those lab experiments, we are going to approach other markets. That's the whole idea. Okay, undergraduate colleges in the US that has physics and chemistry programs. Physics plus chemistry program, we have 9,600, which accounts for roughly $48,000. for $8,000 at $500 each colorimeter. And on the top of that, we have a lab manual that sells on Amazon.com for $10. Okay, our business model, well, we want to license this technology. I'm a scientist, and I have more than 20 patents issued on this technology, both domestic and overseas. Over 2,000 pages of copyrighted materials, trademark materials as well, 3 trademarks here in the United States. Okay, and the competition. The competition has that device that can analyze just one sample, and their price is around ours, anywhere between $500 to $600. Okay, those are the companies that market colorimeters out there, and none of those colorimeters can make multiple sample measurements, just like ours that do. Remember, our colorimeter is actually 3 devices in a single one. Okay? Marketing and sales, if the idea is to license it to someone that already had a foot in the market, so we don't have to worry about marketing and sales. We don't have to reinvent the wheel here. Those are our financial projections. Those are the assumptions that I used. The numbers that you see right in here for the first through 5th years would be revenue by the licensee, and I would collect the royalties out of those sales. Okay, right now our margins is $220 per device. We sell it for $500. Once you optimize the design of the device, the price can go down to $50, increasing our margin to $450, 9 times the cost. So, let's see here. Yeah, our funding requirements. Okay, as an IT guy, I need at least $40,000 a year to keep up with my existing patents. Okay, I have patents both here in the United States and overseas. Okay, and I require as well $150,000 in R&D to come up with new configurations and new products as well. Okay, for the marketing team, for the management team, I have 25 years of experience in this technology. Okay, I started working with this technology at NASA London 25 years ago doing my PhD thesis, and finally it's finally maturing this technology. And I also have a very strong background in IP, in patent protection, IP protection in general. I work with patents throughout the world, here in the United States, also in IP agents that are helping me commercialize this technology, and I have many contacts also in the academic, in the university, both here in the US and Brazil and other countries. I'm originally from Brazil. Okay, so I have 15 more seconds here, right? So let me just tell you, most of those years I was doing...
That's it.
Well, that's 5 seconds. Most of those years I was doing the development of this technology. Okay. And here is the second question.
Do you have any existing revenue? And then the second part of it is what you have put over there as the funds that are required is basically to fund some of the patents that you have existing and to keep you going. But what about actually putting money into manufacturing if you want to make it cheaper, right?
Mm-hmm. Well, the idea is I would like to license this technology. Once I license, I'm hoping I can get a licensee who will do the manufacturing and the marketing and sales. Someone that already has a foot on the market, and
you haven't sold any devices yet?
I have been selling some, but it's kind of small.
How many?
10 of those colorimeters have revenue around $10,000, okay, on sales only. But my overall revenue comes from grants of the government, from the US government in Brazil. In the past, since 2003, I have raised $700,000, including money in sales and agreements with private companies as well.
Claudio, repeat the question so the rest of the audience.
Oh, sure.
Too. When somebody, that's fine. As you move on.
Okay. For a pitch, it looks like you're very good at getting grants and you're asking for money for yourself, but normally in a pitch, somebody's going to invest X amount and they're going to get something, a percentage of your royalties, percentage there. Have you thought about it that way, or is it this really more a grant proposal?
Good question.
Well, I am at the point that I'm moving away from grants. Okay, it's very difficult to get money from grants. Although I have raised $700,000 in grants and sold products out there. Now I'm looking, like I said, I'm looking to license this technology. Okay, and that's the basic idea. If I have the patents, I have 20 years of monopoly of those.
So you're not looking for investors, though, Claudio?
Basically licensing.
No, I mean, you're not looking for investors, though, to come in and be
Right.
partners or part of your organization, right?
Not at this moment, maybe later on. Yeah, but at this moment it's licensing.
No, that was my question, but.
Okay.
Claudio, I'm just surprised that there's no alternate solution. It seems like this would be a problem that dates back at least 25 years. And
Well, it's in the Bible at least.
But, and the Bible piece is just
Since we needed water.
surprising that, and water testing has to be done for so many applications around the world. I find it surprising it's done vial by vial.
Well, what happens, there are different levels of instrumentation out there. The cheapest of them is like just your litmus paper, okay? That you get a paper that reacts with the water and you take a eyeball reading. You cannot automate that. Although it's cheap, you cannot automate that. And you cannot do several analyses, simultaneously, and it takes time to do that. And then you have the graduations of cost, and up to equipment that costs $15,000, $30,000. If you go to the DWP, they buy equipment that costs $15,000 to analyze nitrates. Okay, and here we have a $500 device that can be automated and can be
So there is competition, but it's very high-end, high-priced competition.
high price.
Got new solutions. Any questions from the audience, though? Go ahead.
How easy is it to maintain this particular device? Say one of your light sources fails. Do they have to ship it back to you, or do they have to do it themselves?
Okay, the LEDs has a lifetime of 50,000 hours to 100,000 hours. Okay, we're not using regular lamp bulbs anymore. But of course, eventually one LED is going to fail. So the way I designed the colorimeter is that you can buy another lamp that is going to go with the device, which is a fraction of the cost of the colorimeter itself. Okay.
Okay, very nice, Claudio. Nice job.